So I skipped example 2 because it's a lot like example 1. You just have to review your rules and kind of play with it. If you need help, let me know. Otherwise, we're going to go to example 3, which is example or exponential growth problem solving. So they give us a formula, and this formula is very specific, and you need to understand what all the little bits and pieces are, so that's why I'm taking some time here. They give us a question where it says you invest $1,000 at 6% annual, compounded monthly, and how long is it going to take for you to get to $1,400? Well, that's a whole lot of information, so let's see where that all fits in here. I'm going to start with A, and I'm just going to color code it down here to show you what each of them means. A is your total, so your accrued amount. That's why it's A. That's the total money that you're going to get. So this is talking about exponential growth. They're talking about compounded interest, investments. Those sort of trigger words are going to be what we use this formula for. So A, your total, is how much the whole thing is going to be worth. I kind of hate that they use AO here, initial. So I'm going to change it, and you can make a note or you can just deal with it the way they've got it, because that's the principal. And it makes a lot more sense to me to use a P for principal. So I'm going to use principal there, modify the equation just a tiny bit. So the principal is the amount you start with. So let's just go the money that you start with. So in this case, we know that this is our principal. And we could even add that this one, because it's what we want in the end, is actually our A. So as we go along, we're just going to identify what those values are. Moving into the equation, this is 1. It's going to take the principal value forward, because if you multiply something by 1, it's carrying that value forward. So it's going to be added to the amount of the percent that gets increased. So it's going to be 1 point, whatever the increase is, which is going to carry the initial principal through and increase it by whatever that percent is. So the 1 stays the same, we don't have to worry about it. I is our interest rate, that makes sense. And you have to use it as a decimal. So this is our I, but we want to use 0.06 because that's the decimal version of 6%. N is a little bit odd. That's kind of a new concept for us, and that is this part. So compounded monthly is N. N is the number of times per year that you're going to be compounded. So when it says compounded monthly, that means N equals 12 because there's 12 months in the year. I'm just going to make a little note over here. For N, you might want to make a note for this yourself. If it says yearly or annually, N is 1. If it says monthly, N is 12. Bi-monthly, every 2 months, would be 6. Weekly would be 52 because there's 52 weeks in a year. Daily, of course, is going to be 365, and so on. So those are some ideas of what N is. And when you read the equation, or the question, you have to find it for yourself. So it says compounded monthly, that's N, and it's 12 because there are 12 months in the year. So N is number of times you're compounding in a year. Right. Now, the last thing is T, and that's just number of years. That's a pretty straight read. All right? You've got your stuff here. I'm going to erase this. I'm going to take all of this away, and we're going to work through the formula with those numbers. So, you can pause your video if you need to write it down or whatever. This is really important stuff to understand. Now, this particular question, we're going to plug our values in. I have 1400 for A, so 1400 goes here. I have 1000 for my principal, so 1000 goes here. And then I have the brackets. Guess I should keep within my color code. 1 plus 0.06 over my n, which is 12. You'll notice that the 12 comes in again up here when it's multiplied by the t, and that is because if you have 5 years, but it's compounded every month, then it's actually 5 times 12 that it's compounded, so it makes sense to have it up here as well. So this is what we don't know. We've got all the other numbers. This is what we don't know. So we've got to simplify all these other numbers and move on from there to try to figure out what t could possibly be, which makes sense because that's the kind of equations we've been working with exponentially. So first things first, this 1000 is outside this mucky set of brackets, so we're going to take it over here. I'm just going to use a simple color now. I've got 1400 divided by 1000, which just gets me, these guys cancel out, 1.4. And maybe we'll just do that. So then this is all still in brackets because it's raised to that. This is going to be 1 plus 0.06 divided by 12. Use my calculator. I'm just going to go through this step by step, but once you get comfortable with how to put this in your calculator, you should be fine with it. 0.06 divided by 12 gets me 0.005. Now what that's saying is that, yeah, it's 0.06%, but that's annually. So we're going to divide that by 12 because it's going to be compounded monthly. So this is actually the monthly amount that you're going to be dealing with, and that's what we're going to use to go forward because we're trying to figure this out using the months there as well. All right, so now I've got this number as my base, 1.005 to the power of 12t equals 1.4. Now, you're not going to like this part. You got to graph it. So you can plug this into your calculator, but you really can't because it's 1.4 is y equals 1.005 to the power of 12t. So we have to change it a little bit. What we've got to do is move this 1.4 over to this side of the equation. And so we would leave this as 0 because we're going to be using our y or x-intercept to solve the equation. So it's 1.005 to the power of 12t minus 1.4. Your book didn't actually go into simplification of it. They actually go to, from this step, they make you write all of this in and then subtract 1,400 from it. You should get the same graph either way. It's just a lot more to type in. It just depends on how comfortable you are with your math skills of being able to simplify this, or whether you just want to try plugging all of that in and hope for the best. What you will find is when you use your calculator for this, I'm just going to plug it in here. Y equals, so for me it's just going to be 1.005 to the power of, and I'm just going to put brackets around my 12t just to make sure that I'm not messing things up, and then minus 1.4, graph it. And you might notice that your graph, your window needs to be adjusted a little bit, but I can see that mine looks like it's approximately at, let's see. All right, well, I can show you. It's hard to see because mine's a little bit flat. So what I want to do though is find my 0 right here. So I go second function calc, I want to find my 0, so I hit 2, and my little cursor is right there. Bring it left bound, close to the middle there somewhere. Enter, and then it says right bound, so I'm going to make sure that I'm above the line, so y is a positive number, and enter, and then guess. It's about 5.6. So that tells me that t equals 5.6, because that's the value that goes here when the whole thing is equal to 0, which means that's my x-intercept. And that just tells me that 5.6 years is how long it's going to take to go from $1,000 to $1,400 at a 6% interest rate, compounded monthly.